Welcome back. I hope you enjoyed lunch. And let's be ready to take a trip to Aachen. So this session will be a trip to the test center, I4.0 test center in Aachen. Daniel Steinert will give you a live tour in this center. And thing is, it's not good enough to have a good idea on paper or in your head. Yeah, it's better to test and trial to make sure that it's really fitting to the idea and the needs that you have. And that's actually all they do over there. Yeah, they look at ideas, put them in reality, see how it goes, and adapt to the needs. Daniel, take us to Aachen.
Thank you very much. Welcome, everybody. My name is Daniel Steinert, and in this session, I will give you some insights into our use cases at the demonstration factory in Aachen, our Industry 4.0 test center. In this session, I brought with me 3 of our recently realized use cases that I will show you. But first of all, what is the demonstration factory in Aachen? The demonstration factory Aachen, or as we call them DFA, is a production plant on the campus of the RWTH Aachen. So it is very closely integrated into the university environment of Aachen. It is a custom manufacturer for developing and manufacturing products in the metal processing industry. Moreover, it is also a test center for partners, such as SICK, for example, to test, to develop, and to realize digitalization projects. And what is special about the DFA, we can test our ideas, our digitalization projects in a real production environment and learn a lot of things about them. So the production itself is not fully automated. It is a production that has highly flexible manual, but also partially automated production and assembly processes. And it is an agile production that has the complete value chain from the warehouse over assembly to goods issue. So I want to show you now our first use case that I brought with me, and the name of the use case is IO-Link Retrofit. And what we did in this use case, we did a condition monitoring on a conveyor line to reduce the downtime of the conveyor line. So you see the conveyor line that we have at the DFA on the right side on the screen. And the DFA as a manufacturer knows that digitalization brings benefits to them as a manufacturer because they can improve their processes on the base of data. However, machines on manufacturer sites, for example, this conveyor line, they have very long life cycles. And that means there's always a tension between the invest in a new machine, but also the benefit on the other side. And most of the times, manufacturers such as the DFA even don't know how much costs they have because of the unnecessary downtimes of the machines or unnecessary maintenance of the machines. So what we wanted to do in that use case, we want, of course, to reduce the downtime. We want to make the machine more efficient, and we want to solve this application using sensors and sensor connectivity. As I said, the task is to reduce the errors in the conveyor line and to reduce the downtime. And we want to achieve this by doing a condition monitoring from our sensors. And with the condition monitoring data from the sensors, we get information about the condition of the complete conveyor line. And that means we need more data out of the conveyor line. And for that, we have to use, of course, IO-Link sensors. Those sensors can provide us several data that we need to get information about the conveyor line. For example, one data type could be the sensor contamination. Because in a very harsh environment, if the sensor is contaminated too much, then the sensor goes into an error state and the conveyor line has to stop. And if we could detect the contamination very early, then we can reduce the downtime at this example. On the other side, we want to detect if there is a blockage in front of the sensor. That means if the sensor signal is interrupted for a certain time, because this could mean that there's a box maybe stuck in front of the sensor or a motor broken at this position. And last but not least, we also need the sensor identification data so we know what sensor is sending us what kind of information. And we also wanted, after a changing of a sensor, that the new sensor should be set up and readjusted as quick as possible. And for that, we wanted to do that remotely. So those were the challenges, and I brought a video with me to show you how we set up the use case and what is the outcome of our work. So what you see over here is the previously installed sensors were changed with now IO-Link sensors, and we have an IO-Link master getting the data and sending them to an IO-Link gateway. From there, the data are sent to a PTC Kepware server, a cloud server, and there's a dashboard also from PTC connected with an ePlan view for the wiring of the complete conveyor line. And now you see the conveyor line is starting, and at a certain time, this box is now stuck in front of the sensor, so the switching signal is interrupted for a certain time. And the worker gets automatically notified about this. You see the alarm on the dashboard, and he can select what is the sensor that shows the alarm. And in the 3D view, we see immediately what is the sensor in the conveyor line that is sending us the information. We get information from there about the sensor, but also about the other hardware, the PLC, the motor, and so on. We can immediately jump to the wiring diagram from ePlan as a worker to see how the sensor is connected, and we can also go some steps back and see the exact position where the sensor is located in the conveyor line. So, what were our technical changes? First of all, as I said, we replaced the old switching sensors and now use new IO-Link sensors. And with this IO-Link sensors, we have a lot of more information about the conveyor line. The IO-Link information are connected to an IO-Link master that has a web-based interface, in this case a REST API, and from there we can transfer the data to the server. But what is very special, the switching signal from the sensor is still connected to the PLC, so that to the PLC, the machine now operates exactly like the machine operated with the previously installed sensors. The PLC just gets the switching signal, and for us, we have the benefit that we don't have to reprogram the PLC or change anything in the program code. The IO-Link data are retrieved from the IO-Link master using an IoT gateway, and this gateway puts the data into an OPCUI server where our Kepware server has access to get the information and brings them into the cloud dashboard. Our benefits are that we have a reduced downtime because we get very early information about the contamination of the sensor. New sensors after we change them to set them up really quickly and readjust them really quickly. The next use case I want to show you is called Smart Storage System, and in this use case we have a container for hazardous materials, and we installed a guided storage, but also a worker and a material identification. So the task is the following, and this is really common in the industry. It is really common that production plants have to store hazardous materials. And there are, of course, a lot of regulations, a lot of standards that you have to take care about when you are working with these hazardous materials. And those standards are depending on the properties of the material, of the quantity of the material, and a lot of more things that you have to take care about. And this means you have to find a solution how to store those materials. Often, also in the DFA, as you see on the screen, in the industry, there are walked-in hazardous material storage container used, and those containers are right now not digitalized at all. That means all the information about what material is inside, in what quantity is it inside, what are the properties of the material, what are my workers that have access to the storage, and when did they last enter the storage, what is the exact position inside the storage where my material is located. All of those informations are not captured digitally, cannot be seen digitally, and have to be written down manually. This means a worker has a great responsibility to ensure that he is using the storage and that he is fulfilling all the standards and the regulations. Of course, putting all the information down to paper or putting them manually into documents is very time-consuming and, of course, very vulnerable to errors. And as I said, we have no information where inside my storage what material is located. And these were the tasks for our use case. And I have another video with me to show you what we did and how the storage now looks like. So first of all, we have a worker identification and an identification of the hazardous material in front of the container. So the worker has to log in, and we have a conversational artificial intelligence, let's say a bot, that is interacting with the worker. And the worker is now asked, what does he want to do? He wants to store some material, and he says this by words, and the bot understands him and tells him now to identify the material, which is acetone in this case. And now in the back end, the system checks if it is allowed to store this hazardous material inside of the container. And now he asks in which quantity, and the worker says 20 liters. And now in the backend, automatically, the perfect spot for this material, depending on all the regulation and standards, is found. And the worker gets also the information about the material, all the security information. But not only that we show him the security information, in this case for acetone, he has to work a safety glass and gloves. And there's a camera system checking if the worker wears this equipment properly. And we see that the worker is wearing the gloves, but not the security glasses, so he is not allowed to be to store the material inside of the container. Okay, now he puts on the glass, the check is there, the door only now opens for the worker, and we have the perfect spot, depending on all the regulations, for the material. Inside we have a pick by light or put to light system. This is also controlled with 6 sensor solutions, and we see now that the worker puts the container into the wrong storage position. And we detect this, of course, and tell them, okay, worker, you cannot do this, you have to put it in the marked zone. Okay. Now, this is also recognized by our SIG sensor solutions, and the information are sent to an ERP system that the workmate in the office knows exactly what material in what quantity is stored where at the container and can find all these informations. So we have an ERP system set up. You see the alarm over here, and the worker gets the information and can search for the hazardous material and find them inside and where they are located inside of the container. So from SIG side, as a summary, what we did, we installed an access control, and we made that possible using RFID as a worker identification, and we use a barcode scan as a material identification. And inside of the storage, we have sensor solutions that detect if there are material inside the shelves. And for those, we use 3 different types of our solutions. We have reflective sensors, we have light grids, and we have LiDAR scanners to show also what are the different technological things, how we can solve this, and what are the benefits and the disadvantages of those different solutions. The benefits are, of course, now it is very simple to work with the container. And this is because you cannot possibly do anything wrong, and the bot helps you, is guiding you through the system and interacting with you. We have, as you saw, also the automated booking inside of the storage, and there's also the automated suggestion, what is the perfect position for the hazardous material, and this is, of course, depending on the regulates and standards that we have to fulfill. But this means also that now the challenge of working properly is now shared not only with the worker and not only in his responsibility, but also shared with the storage system. That means also we have a very high error and damage limitation and prevention. And as you saw, there's a high transparency or full transparency of the storage, because from the ERP system, you can find immediately all the hazardous material and where they are located and all the information. That means also that we ensured the legal compliance, and last but not least, we have an increased efficiency, but more important also an increased safety when it comes to working with hazardous material. The third and last use case that I want to show you from our demonstration factory Aachen is called future logistics. And in this use case, we have a seamless material tracking and material identification system running at the DFA. So the DFA had the task that they wanted to optimize their intralogistic processes because they spent a lot of time on searching for the materials, for their goods, and a lot of information during the production they wrote on paper and connected them to the transport card, and then the information often were lost or couldn't be read anymore. So what they wanted to have was a seamless material tracking, material, goods, and resources identification to save their costs. They wanted to locate them and identify them very easy, so they don't have to search for them very long. And what they also wanted to have, they want all this information about the processes, about the track and tracing inside of the ERP and MES system to give automated feedback live during the production and to optimize their processes on the base of the production data. Yeah, and this means we had to connect all of the information to systems, ERP and MES systems, and we had views for all the different stakeholders or roles in the production. So for the warehouse roles, for the assembly section, for the delivery parts. So all the information through the entire value chain had to be tracked and brought to the ERP and MES system. And for this, I also have a video, what we did, and I will show you now. You see our partners that were also included in the project over here. And in this project, we have an AGV we use for transporting the material as well. So the use case starts, of course, in the warehouse, because when there's a new production order, the worker has to pick all the goods that are needed. He scans now with the barcode that he starts the picking process, and we check this with a timestamp. And now he is checking the transport card and the handling unit. So now they are linked together for this production order. He sees a list of the picking material that he needs, and when he picks the material, he also scans the ID of that material. So this is as well connected to the production order. And with every working step, with every process, we set a timestamp for the worker, so we know through the complete process what are the target processing times, picking times, for example, and what are the actual picking times. So we can identify time delays very fast as possible. The picking now is completed, and the AGV comes to move the parts to the assembly line. And the AGV can be tracked in the complete production hall using UWB. So the AGV is completely transparent. We always know where our material is, where our order is. And of course, the AGV inside our factory is also saved by SIG laser scanners, and the people are saved. This is a special use case because we have a laser scanner connected via 5G directly to the AGV, but this is a different use case in Aachen. And now the parts are arriving at the assembly station, and the worker is taking the handling unit. This time with RFID, we are scanning what is the production order, and based on the product that has to be assembled, there is a worker guidance showing the worker the steps to assemble this product. And all of these processes, all of these assembly steps are also tracked with a timestamp, so we know how long each process took, and we can get all the information live in real time. Now the product is assembled completely, and the delivery starts. So now the complete product is brought to the customer. Okay. Yeah, again, as a summary from SIG side was what we did. We track all the material identification via RFID technology, but also via 1D and 2D code. And we track the AGV using UWB localization inside our factory. And the benefits are, sorry, There's a black screen right now. The benefits are now that we have a seamless track and trace inside our production line. We know where the products are, so this saves us a lot of time, a lot of costs. When there are time delays, we can see them immediately during our production, and we can react to them really, really fast. Okay, my last slide would have been some more information about the DFA. No problem. Okay, thank you very much. But now the tool is not working anymore. No problem. So if you want to get more information about these 3 use cases or about our other use cases at the demonstration factory in Aachen, just search for DFA and SIG. You find them on our webpage. You find information about our workshop and our visit opportunities, and you can contact us immediately. I'm looking very forward to your visit in Aachen, and now I'm really looking forward to your questions.
And it's good to see the ideas getting or being put into reality and into real test cases. We have a few questions in the chat. Let me have a look. First one, is it possible to see the use cases live? I mean, can we visit the test site?
Yeah, yes, of course. So as I said, the information are on our webpage. So we have visit opportunities, but we have also an Industry 4.0 workshop where the customer can get information how we focus Industry 4.0 projects, how we plan them step by step, that they are realized very easily, and they can talk to us as digital experts, but also to our partner companies to get all the information how to deal with digitalization at their production plant.
Okay. Second one, at the future logistic use case, who provides the UWB information?
Yeah, so the UWB system we have at the DFA is also provided by SIG. So we scan the UWB tags, and we have a software that is called Asset Analytics, showing the information. That was also the software you saw in the video. And this software also allows to include RFID data, barcode data, so identification data from our other SIG sensors, and puts this data together and send them to systems like an ERP system, like SAP, for example. This we will also see in the next session.
You're just taking the words out of my mouth. I was just going to say that especially the third example seamlessly fits to the next session, which is about smart logistics and the integration in SAP. So thanks a lot again.
Thank you very much.
If you have interest in this test facility, go to your local contact and we'll make it happen. Thanks a lot, and let's see each other in a few minutes for the next session.
Thank you very much.
Thank you.